Hello friends, welcome to our channel. Today we shall discuss on radius of curvature in case of polar curve. So the radius of curvature in polar curve, the equation is given by r is equal to f of theta, where r is the radius and f is the function and theta is the angle. So to derive the equation of radius of curvature in polar curve, let us draw a simple line. So let us consider the line with the x and y axis. So consider this as the x-axis and this as the y-axis. So now we shall draw the triangle. So then we shall draw the tangent, that is the curve, and the angle made by the curve is phi. And this is the polar curve with the P is the point with the radius r, and the angle made by the curve is theta. And then angle with respect to this triangle is theta, and this is the exterior angle. So the exterior angle is phi, and this hypotenuse is considered as the radius r. So this is the arc A, or you can call it as the curve. So this is the origin O. So let us define OP is equal to R. So this is the O. This is the origin, that is a 0, and this is O and P. So let OP is equal to, we have taken it as the radius R. OP is equal to R. Be the radius vector, and phi be the angle made by radius vector with the tangent that is P of r comma theta. So we have taken phi is the angle, and then the tangent T, or you can call it as the RK. So it is taken as P of r comma theta. So then let phi, this is the psi, be the angle made by tangent P with the initial line, that is, you can also call it as the exterior line, the line which is extended. So we have taken it as the angle psi. So then let A be the fixed point on the curve. So we have considered this as the curve, and then we have taken it as the point A. We have defined it as the point A, and let AP is equal to, you consider it as the S. Then we have the psi is equal to theta plus phi, that is the exterior angle psi is taken as the sum of two interior angles. So the interior angles are phi and theta. So we have taken it as psi equal to theta plus phi, or phi plus theta. So the next step is we need to differentiating, we have, that is d psi with respect to s. D psi with respect to s is taken as, that is, differentiation of theta with respect to s plus differentiation of phi with respect to s. So we can write it as d theta divided by ds plus d phi by ds into d theta by ds. That is, as you know that the rho is given as ds upon d theta divided by 1 plus d phi upon d theta. So this equation we have derived in earlier videos, and then we have tan phi equal to r into d theta divided by dr, or you can write it as r divided by dr upon d theta. That is, we have considered it as a tan phi equal to, so this is a standard formula. That is tan phi equal to r into d theta upon dr, and in terms of reciprocal we can write it as r divided by, so d theta will be in the denominator, it will be dr upon d theta. Then again differentiating, here we have differentiated with respect to s because we have considered the angle AP to be s, and now we shall differentiate with respect to theta. So differentiating the tan phi with respect to theta, so differentiation of tan phi is nothing but it is sec square phi. So it will be sec square phi into differentiation of phi will be d phi with respect to theta, it will be d theta is equal to, so differentiation of r, so r differentiation of r will be r1 into, then again it will be r1 minus, then keeping r as it is, so r into, then again differentiation of r1 will be r2 divided by r1 square. We need to apply the u by v formula, that is u by v formula we need to apply. Then we know that where what is the second derivation of r2 is nothing but, so it will be d theta upon dr. So here r divided by dr upon d theta is there. So we have applied the differentiation with respect to theta. So it will be r1 square, differentiation of r will be r1 square. Then after that you need to keep r1 as it is into differentiation of r will be r1 minus keeping r as it is into differentiation of again r1 will be r2. So we can write the second derivative of r2 as d square r upon d theta square. We have found that sec square phi into d phi upon d theta is equal to r1 into r1 minus r into r2 divided by r1 square. So we need to find, our aim is to find the d phi upon d theta. So we can write it as d phi upon d theta is equal to, it will be r1 into r1 will be r1 square minus r into r2 divided by r1 square into, so we have considered d phi upon d theta, so sec square phi will go on the right hand side, so it will be r1 square into sec square phi. So this can be written as, you need to express this in the form of tan, as we know that sec square phi is nothing but 1 plus tan square phi. So just substitute 1 plus tan square phi in place of sec square phi. So it will be r1 square minus r into r2 divided by r1 square into 1 plus tan square phi. So the next thing is d phi upon d theta is equal to r1 square minus r into r2 divided by r1 square into, so 1 plus, as you know that the tan square phi, so it is tan square phi, tan square phi is nothing but it will be r square divided by r1 square, because we have considered tan phi is equal to r divided by dr upon d theta, as we know that dr upon d theta is nothing but r1. So therefore just substitute in place of tan square phi as, so tan square phi is replaced as, so the second derivative, so tan square phi is nothing but r2, so r2 divided by r1 square, because it is tan square phi is there, so just write r1 square, then r1 square minus r into r2 divided by r1 square, just multiply, so r1 square, then it will be r1 square then plus, so it will be r1 raised to 4 divided by r1 square, so just cancel, so it will be r1 square minus r into r2 divided by r1 square plus, so 1 square gets cancelled, so remaining will be, so it will be just r square. So therefore we can write it as, hence we can write it as 1 plus d phi upon d theta can be written as, so d phi upon d theta is nothing but r1 square minus r into r2 divided by r1 square plus r square. So we need to write 1 plus d phi upon d theta. 1 plus d phi upon d theta is nothing but 1 plus r1 square minus r into r2 divided by r1 square plus r2. So then if I cross multiply it, so upon cross multiplying we can write it as it will be r square or r1 square plus r square, it is r square, then minus r into minus r1 square minus, so this will be, so first initially you need to multiply this, it will be r1 square plus r square, then plus r1 square, again you have plus, because plus, then it will be r1 square, then plus into minus will be minus, then it will be r into r2, then finally r1 square plus r square. So then you can write it as 1 plus d phi upon d theta is equal to r square plus, we have r1 square and r1 square, so we can write it as 2r1 square, then minus r into r2 divided by r1 square plus r square. So also we know that you can write it as ds upon d theta. So ds upon d theta, we had d square s upon d square theta. So we can write it in terms of square root. So that will be square root of r square plus dr upon d theta whole square. Or you can write it as the square root of r square plus r1 square. Because it is r square and dr upon d theta is nothing but the differentiation, that is r1 is nothing but dr upon d theta. So just write it as r1 square. So then therefore we can write it as rho is equal to r square plus r1 square into and whatever we have obtained here. So we have obtained that it will be r square plus r1 square divided by r square plus 2 into r1 square minus r into r2. So this we have just substituted d phi upon d theta. So d phi upon d theta is nothing but we have taken it as r square plus r1 square into, then we have represented in the form of d theta upon d phi. So d theta upon d phi means we have taken it as the r square plus r1 square, square root of r square plus r1 square into, so d theta upon d phi means it will be r square plus r1 square divided by r square plus 2 r1 square minus r into r2. And also we know that ds upon d theta, also ds upon d theta we have written it as, that is we have written it as square root of r square plus dr upon d theta the whole square. So this we have taken it as r square plus r1 square. So just we have substituted this, that is rho is equal to, rho is nothing but we had discussed earlier that rho is nothing but it will be ds upon d theta divided by 1 plus d phi upon d theta. So just we have substituted the values, that is we have substituted the value of ds upon d theta, that is ds upon d theta is nothing but r square plus r1 square. So r square plus r1 square into 1 plus d phi upon d theta. 1 plus d phi upon d theta is nothing but, so it will be divided by, so divided by 1 plus d phi upon d theta. 1 plus d phi upon d theta is nothing but r square plus, so that is it will be denominator. So if you take in the numerator, it will be r1 square plus r square divided by r square plus 2 r1 square minus r into r2. Thus we can write that, thus the polar form is given by, that is rho is equal to, we can write it as r square plus r1 square. So here also we have r square, here also we have r square plus r1 square into r square plus r1 square. So we can multiply it and we can write the square root in terms of 1 by 2. So it is same as that of writing square root. So then after that divided by divided by the remaining as r square plus 2 into r1 square minus r into r2. So it will be, so square root will be 1 by 2, and then here it will be square root will be 1 by 2, then again here we have, then here it will be in the power of 1. So we need to write it as, we can write it as r square plus r1 square into, it will be 3 by 2, because this is the square root and we are eliminating the square root which is raised to 1 by 2, and here we have power 1. So then by multiplying both, we will have r square plus r1 square divided by 3 by 2 raised to 3 by 2 divided by r square plus 2 into r1 square minus r into r2. So this is the standard polar form. That is, we can write it as rho is equal to r square plus r1 square raised to 3 by 2 divided by r square plus 2 into r1 square minus r into r2. So this is the standard radius of curvature in case of polar form. That is given as r square plus r1 square raised to 3 by 2 divided by r square plus 2 into r1 square minus r into r2. Thank you friends. Subscribe our channel for more updates.